Okay, so Chapter 2, Section 3 is over lines. I'm biased toward this lesson. If you've looked at the homework assignment, you've already noticed that. This lesson pretty much encompasses my entire capstone. So my master's program, so I've wrote a lot of papers over lines and all these equations. This page right here is your guide sheet pretty much to getting through this. So this is how to find slope. So slope, rise over run, so y over x. The delta just means change in y over the change in x. A bunch of people asked me about that in class, so that's what that means. And then here's the formula: y2 subtract y1, x2 subtract x1. And m is the variable they use for slope most of the time, so x1, y1 would be part of point 1, and then x2, y2 would be from point 2. Just a little clarification there. I widened this out here because I about wrote equals, so if you can see that smudge there. Slope-intercept form of a line: y equals slope times x plus b, where b is the y-intercept and m is the slope. Point slope equation of a line, so y subtract y1 equals slope times x subtract x1, where x1 and y1 is a point and m is still slope. On the back of this paper, we have a vertical line. So vertical line is when the slope is undefined, where a is the x-intercept. So if they gave us, they told us the slope is undefined and the point is 2, 3, the equation for that line would be x equals 2. So if they tell us we have a vertical line with the point -6, 5, the equation would be x equals -6. You need to remember this for your test, because the majority of your test is going to be over 2.3 in the first place, so I hope you've watched this one this far. Horizontal line, so y equals b, where b is the y-intercept, slope is 0 on these. On these, it's nice because if you don't remember how to do this one, you can plug it into the point slope form and work it out. But on the vertical lines, you can't do that, because how are you going to put undefined into one of the equations that was on the other side of this paper? So this one, if they tell us we have a horizontal line and the point -3, 4, it'd be y equals 4. Or if they tell us the slope is 0 and the point on the line is 2, -6, it's going to be y equals -6. But if you didn't remember that, you could also work out the point slope form, or even the point slope form. So we'd have y subtract -6 equals slope is 0 times x subtract 2. And that's the point slope form of an equation. 0 multiplied by all that is 0. So we'd have y plus 6 equals 0. Subtract our 6, so y would equal -6 still. So that's why I said this one, if you don't remember that undefined is just x equals, you can still plug this one into this equation. But this one you kind of just have to remember. You can graph it and it be a vertical line. It's never going to touch the y-axis unless it is on the y-axis. But even then, it's x equals 0. Parallel lines have the same slope, so we'll go over that one more when we get to that example. And then perpendicular lines have the opposite reciprocal slope. So if they gave me one of them was -1/2, the opposite reciprocal of -1/2 would be a positive, and the reciprocal of 1/2 would be 2, because it'd be 2 over 1. So if we had -2/3, the opposite reciprocal of -2/3 would be positive 3/2. And then if we had positive, we'll say 5, the opposite reciprocal of positive 5 would be -1/5, because we'd assume it's over 1. Okay, let's start on some of the examples in the next video.